All right, let's jump right in. Today, we're talking about something pretty incredible, the nervous system. You can think of it as your body's command center, right? It's this high-speed network that controls literally everything, every move, every thought, every single thing you feel.
But what happens when that command center gets compromised? When the signals get crossed or damaged or just plain interrupted. Well, that's exactly what we're going to dive into, focusing on all the key stuff you'll need from Chapter 10 of your textbook.
So here's our game plan. We'll start with a super quick refresher on the command center itself. Then we'll get into disorders from trauma, what happens when signals go haywire, and conditions that show up during development. We'll also hit on pain from nerve pressure, and then wrap things up by looking ahead at the future of treatment. Ready? Let's do this.
Okay, first things first. We need a solid but quick foundation. The nervous system is basically the master regulator of your whole body, and really getting a handle on its basic setup is the key to understanding all the disorders we're going to talk about.
So it's split into two main parts. You've got the central nervous system, the CNS, which is like the headquarters. That's your brain and spinal cord. Then you have the peripheral nervous system, or PNS. Think of that as the massive network of nerves branching out, carrying all the messages to and from the rest of your body.
All right, let's switch gears and talk about what happens when physical force smacks into the system. These are some of the most common and, frankly, most sudden nervous system disorders out there.
First up, concussions. And listen, this is a big one, because the way we think about concussions has totally changed. It's not something you just shake off anymore. We now know it's a serious brain injury, one that absolutely requires weeks of careful treatment and recovery.
So, what are the red flags? You're definitely going to want to know these, especially for your tests. They can be really obvious, like losing consciousness or feeling dizzy. But they can also be more subtle, like that frustrating brain fog where you just can't concentrate, or persistent headaches, nausea, and even some pretty noticeable personality changes.
Now, moving from the brain down to the spinal cord, there's a simple but critical rule you have to remember. Location is everything. The higher up on the spinal cord the injury happens, the more function is potentially lost throughout the rest of the body. It's a direct relationship. And that brings us to maybe the single most important first aid rule, and I really can't stress this enough. If you even suspect a spinal injury, you do not move that person, period. Keeping their spine still until medical help gets there can literally be the difference between a fracture that heals and a permanent life-changing injury.
Now, trauma is a major cause of damage, for sure. But not all nervous system problems come from an outside force. Some actually start from within, when the system's own wiring starts to break down. And that brings us to a really crucial part, the myelin sheath.
This slide gives us a perfect visual. See on the left? That's a healthy neuron. That protective coating around it, that's the myelin sheath. It's like the insulation on an electrical wire. It helps nerve signals travel super fast. But look at the neuron on the right. When that sheath gets damaged, the signal slows down, it gets garbled, or sometimes it just gets blocked completely.
Okay, pay close attention here, because this table is pure test material. We're comparing three conditions that all cause weakness, but they are very, very different. With multiple sclerosis, or MS, the myelin in the brain and spinal cord is attacked, which messes with coordination. ALS is different. It affects the motor nerves, causing paralysis that's irreversible and, sadly, often fatal. Now, the key thing with Guillain-Barré is that even though the immune system is also attacking the nerves, the effects can often be reversed if it's treated in time. Knowing those distinctions is absolutely crucial.
Next up, let's look at conditions that are either there right from birth or that tend to progress and get worse over a person's lifetime. These are what we call developmental and degenerative conditions.
Spina bifida is a developmental condition. It all happens really early in a pregnancy, when the bony spinal column just doesn't close all the way around the spinal cord, leaving it exposed and really vulnerable to damage.
But here's where things get absolutely incredible. Modern medicine has found ways to fight back. With early detection, doctors can sometimes perform surgery while the baby is still in the womb, or they can plan a special C-section to protect the spinal cord. It's amazing stuff that can dramatically improve the outcome.
And another developmental one is cerebral palsy, or CP. This is actually a whole group of disorders, and it's caused by a lack of oxygen getting to the brain while it's developing, either before or during birth. The main things it affects are movement, balance, and posture. Okay, now for the degenerative side of things. Let's compare two big ones you've probably heard of. Parkinson's is all about movement. It's caused by a drop in a chemical messenger, a neurotransmitter, called dopamine.
That's what leads to those classic tremors and a shuffling walk. On the other hand, you have dementia, and its most common form, Alzheimer's, which is all about cognitive function. It's caused by actual physical damage to nerve cells, leading to things like memory loss and trouble with reasoning.
All right, our last category of disorders is about something that a lot of us have probably felt at some point, pain that comes from a nerve being squeezed or compressed.
Headaches are the perfect example, and it's really important to note they are not all the same. A tension headache often feels like a tight band of pressure wrapped around your head. A migraine, that's usually a severe throbbing pain, a lot of times just on one side. And then there's a cluster headache, which is known for just excruciating pain, usually centered right around one eye. Two other really common examples here are sciatica, that sharp, shooting pain that can go from your lower back all the way down your leg, and neuropathy. Neuropathy is a broader term for nerve damage that causes tingling, pain, or numbness, most often in the hands and feet. So, after covering all these different disorders, you might be asking, what does the future hold? I mean, where is all the science and research actually headed?
Well, the reality is, for many of these conditions, from ALS to Alzheimer's, we don't have a cure right now. But that is absolutely not where the story ends. The really crucial takeaway here is that research is always relentlessly pushing forward. Scientists are constantly developing new treatments to manage symptoms, to slow these diseases down, and to just dramatically improve the quality of life for millions of people.
And that leads us to a final question, something to really think about. With science moving as fast as it is, which of these really complex disorders do you think we might actually see a cure for in our lifetime?
And to take this a step further, I really encourage you to pick one of the conditions we talked about today and dig into that enrichment activity in your text. Doing a little research for a paper or a poster will deepen your understanding way beyond what we can cover in a quick explainer like this. Thanks so much for tuning in.